In this section, I want to talk about route summarization, and I want to give you two examples about route summarization so that you can master this technique too. For example, we have 10, 10, 10, 0 slash 24. We have 10, 10, 11, 0 slash 24. This is my next subnet. And I have 10, 10, 12, 0 slash 24. Now, they ask me to give them a summary address out of these component IP addresses. And I call them component IP addresses because they can be summarized into one IP address. Okay, now how can I do that? First of all, I should, find out which octets are similar to each other. You see that the first two octets are quite similar. So we have 16 bits in common, okay? Now, the third octet is different, so we should go for the third octet and try to convert it into binary. You know that 10 is 0, we don't have a 128, we don't have 64, we don't have 32, we don't have 16. We have an 8, and we don't have 4, we have a 2, and we don't have 1. This is 10 in binary. So 11 is easy. You should write 0, 0, 0, 0, 1, 0, 1, 1. And 12 is easy too. 0, 0, 0, 0. And this is going to be 1, 1, 0, 0. Okay. This is a conversion into binary. The third octet is converted into binary. Now, I should find out how many bits are similar in this, binary conversion. You can see that my first 5 bits are quite similar to each other in these 3 octets. You can see that all of them have 0, 0, 0, 0, 1. And the rest of the bits are different. You can see that this has 0, this has 0, but this has 1. So we do not work with these different ones. We are just interested in what do you call it? The similar bits, huh? Okay, we have 5 bits in common here, and we have 16 bits here. So 16 plus 5 is going to be 21. So we have 21 bits in common. So my IP address, my summarized IP address is going to be 10, 10, and I should find out the third octet. The fourth octet, of course, is 0, and there is a slash here, and after that, 21 bit in common gives me a 21 bit summary, a 21 bit network mask. Okay, so what is the third octet? I should figure out the third octet. You can see that this has a value of 128, but this is 0, so it has nothing. This has a value of 64. Again, it doesn't have any value. This has a value of 32, but it is, 0, 2. This has a value of 16. Again, all bits are 0, so we do not have anything with this. The last one has a value of 8, and you can see that this bit is on. So this is going to be 8. 10, 10, 8, 0, slash 21 is a summary of these 3 networks. So how can I make sure that this is the IP address? This is the summary address that I can get out of these component IP addresses. I can go for these 3 bits, and you can see that these 3 bits give me 2 to the power of 3, about 8 different possibilities. So you can see 8 here. And if I want to write the rest of the subnets out of this, I can have 0, 8, 15, no, 16, of course, and 24, and it goes to 248. This is the last one. So you can see that all of my IP addresses are 10, 11, 12. between 8 and 16. So they can go into this subnet. So I'm sure that this is the correct subnet that I have created. Okay, I want to give you another example so that you can be quite comfortable with route summarization. They give me this. They told me 192, 168, 25, 0/24. They give me 192, 168, 31, 0/24. They give me 192, 168, 8/0, .0/24, and of course 192, 168, 15, 0/24. So they give me these four subnets, and they ask me to summarize this into one summary address. So these are going to be components IP subnets of a summary. So again, I can see that the first 16 bits are quite similar. So I have 16 bits here. Okay. Let's go for the different octet. Here, the third octet is different. You can see that the first one is 25. I want to convert it into binary. 25 in binary is this. It doesn't have 128, it doesn't have 64, it doesn't have 32. It has a 16, and the rest is going to be 9. So it has an 8, the rest is going to be 1. So it doesn't have a 4. It doesn't have a 2, but it has a 1. So this is a conversion of 25 into binary. For 31, so we don't have 128, we don't have 64, we don't have 32, we have all of them here because we have a 16, the rest is going to be 15, it has an 8, the rest is going to be 7, it has a 4, the rest is going to be a 3, it has a 2, and the rest is going to be 1, and it has a 1. Okay. So for 8, it is quite easy. 0, 0, 0. So 128, 64, 32, 16, 8, and the rest is going to be 0. And for 15, again, it is so easy because these are going to be zeros, and the rest are going to be 1. Okay, this is the conversion of these bits into binary. Now I should find the common bits here. You can see that up to here we have common bits. All of them are zeros, but the rest are different. Some are zeros, some are ones. So we have 3 bits in common. So we have 3 bits here. So 16 plus 3 is going to be 19. So we have a /19 here. 192, 168, these are quite similar. The last octet is going to be 0, and the third octet that is different. We should find the value of these 3 bits. All of them are 0, so this is going to be 0. So it is going to be 192, 168, 00/19. So this is the summary of these 4 component IP addresses.